We're now going to do the same test as we just did, but now we're going to do it another way, the way that we'll do it from here on out, and that is using what is called z-values, calculated z-values. The logic behind this is not too difficult. It's a concept we learned in 214. Let's draw two distributions here. Alright, first distribution, the distribution we just used. Distribution of p hats, the middle of that distribution was the limit on the error rates from being satisfactory, the 2%. We calculated an upper limit, 0.03628, and we then found the sample value to be inside the acceptance region, 2.5%, about there. The way we're now going to do it, at first it sounds or feels unintuitive and cumbersome, and in the long run it'll help us. Alright, so we're going to drop that down. The middle of the z distribution is 0, so the 0.02 corresponds to 0 on the z. Alright, the 0.03628 was the limit, critical limit, that gave us the alpha of 1% in the upper tail, and so we're going to have 1% in the upper tail on the z, and we sort of already know what that is since we used it to calculate that upper limit, 2.326. Alright, so our decision rule is now going to be in terms of z-values. We're going to say if the calculated z-value is less than or equal to 2.326, do not reject the null. If the calculated z-value is greater than the critical z-value of 2.326, we're going to reject the null. And when we're done with all that, then we will do our calculations and find the z-value corresponding to the sample value, and we'll call that z-calc, or calculated z-value. Alright, and so that's where we're going, and let's now do that. Alright, so we start this test off the same way. Same sample data, n is 400, p hat of 0.025, 2.5%, and the work is satisfactory if p hat is, if the true proportion p is less than or equal to 2%. Alright, so, and this the same routine as before. We have a one-tail test, and we say which tail, and once we've decided it's a one-tail test, we do the same routine as we've done before. It doesn't change because of the way we're going to do the test. So which tail sample proportion, 2.5%, is greater than the 2% limit, so it's an upper tail test with the alternate being the true proportion, which we don't know, is greater than 2%. Alright, so the alternate greater than 2%, not satisfactory, null less than or equal to 2%, the work is satisfactory. At this point, things change. We'll draw a diagram. Draw a z distribution this time. Distribution of z values. Middle of the distribution is 0. We'll have the alpha of 1% again in the upper tail, but of course on the z distribution that's a value of 2.326, and we'll do a decision rule in terms of that. So the decision rule will work as follows. If the calculated z value from the sample is in the acceptance region, do not reject the null. It's possible the work is satisfactory. If the calculated z value from the sample data is greater than 2.326, then we will reject the null. It is likely the work is not satisfactory. Okay, so let me write that down. Alright, so here we have it. The only thing that has changed is that we now have z values. So instead of saying if p hat is less than whatever, do not reject the null as possible work is satisfactory, we have if z calc is less than the critical z value 2.326, do not reject the null as possible work is satisfactory. And then if z calc is greater than 2.326, then reject the null, accept the alternate. It is likely the work is not satisfactory. Alright, at this point we do our calculations. Okay, so we now calculate z calc, and for a proportions test of this type goes as follows: p hat minus p divided by the standard deviation of the p hats. Alright, p hat is 0.025 minus the p, the middle of the distribution, 2%, 0.02, divided by, and the standard deviation, as we had from last time, is 0.007. And I have it written wrong over here right now, it's 0.007. Alright, so the calculated z value is equals, parentheses for the top line, 0.025 minus 0.02 divided by, close parentheses, divided by the 0.007. And we really don't need 4 significant places here, but for 4 significant places here, that's 7143. Alright, 0.7143. Why did I say we don't need 4 significant places here? Well, the z values only go to 3 decimal places, but that's alright, we can use that. Alright, and so the 0.7143, just as we had for the sample portion, 0.025, is right in the midst of the acceptance region. Alright, and so our decision will be, since z calc, calculated z value based on the sample data, is 0.7143, it means that the 2.5% is 0.7143 standard deviations above the 2%, since that is clearly much less than the critical value of 2.326. We cannot reject the null, do not reject the null. And the same interpretation, it is possible the work is satisfactory. Alright, so every test that we have done up to this point in terms of calculated z value, calculating the critical limits, can also be done with calculated z values. In the short run, as I said before, it looks unintuitive, but in the long run we will get a feel for the size of z values, and it won't seem so strange after a little while. And that's the end of this story.